Structure and property of metallic compounds. So again, if we go back to the flowchart, we can see that the bonding is metallic, the structure is called giant metallic, and the forces holding our particles together this time are electrostatic forces of attraction between positive ions and delocalized electrons. So a little bit different. They're not oppositely charged ions this time, positive ions and delocalized electrons. So if we go to our metallic bonding page and we think about writing down our structure, we're going for a giant metallic lattice. And our bonding is metallic. And our forces are strong forces of attraction, not between oppositely charged ions though, strong forces of attraction between positive ions, so they're the metal ions, and delocalized electrons. So our first thing we're going to look at is why they have high melting points. So they have high melting points because it takes a lot of energy to overcome the strong forces of attraction between positive ions and delocalized electrons. Why do they conduct? They always conduct, whether they're solid or liquid, because the delocalized electrons are the charged carriers and they can move through the structure and carry current. Why are they strong? Well, because they have these strong forces. So you can see these forces between the particles are very important. They come up in all our answers. And then we have our two properties that we might have learned at GCSE: malleability, that ability to make it go into different shapes, and ductility, or a metal is ductile, can be drawn into a wire. So why can metals do that when other things can't? If I were to try to do this to an ionic crystal, it would shatter and fall apart, fly apart. But when I try to do this to a metal, this doesn't happen. And it's very important that you're very clear with this, that when you hit it with a hammer, the layers, and that word is so important, of ions slide over each other. So in this giant lattice can slide over one another without disrupting the forces, because the glue, the delocalized electrons, still hold it in together. Okay, so they can slide over each other, whereas in an ionic crystal, when they try to do that, they start to repel. Here, the layers can slide over each other without disrupting the metallic bond. The attraction between positive ions and delocalized electrons remains.